Hi, my name is Sean. I work for Extrupet, and what we've done here today is we've officially launched the plant at ProPet in Cape Town. And today we've taken a lot of our partners that were able to join us today through the plant. Just to give you a bit of a summary as to start to finish, what happens in our context is bottles are collected from the environment. Those bottles are then processed in terms of sorting and cleaning. Once the sorting and the cleaning has been done on the bottles, we then chop them up into flakes. The flakes themselves are then sorted and cleaned as well, and then those are processed through our plant that we are showing everyone today. The process that we're going to walk through is flakes are produced, and the flakes are then made amorphous chip, and then from amorphous chip it's converted into rPET pellet. That rPET pellet is made to a certain specification, a 0.82 IV intrinsic viscosity of an L-star value of 68 and of a AA level of less than 1 ppm. So that's the global specification that we make the food grade rPET to, and that rPET is then sold both locally and internationally. A lot of our knowledge over the last 25 years has been around how you process bottles, how you get them ready to make them back into a food grade rPET can. And we've gone from an environment a few years ago where everybody was using 10% to now a lot of brands are well in excess of 50%. We have brands using 100% food grade rPET. So it's wonderful to see the output of the process. We have automated systems for both the bottle sorting and the flakes, and we also have manual systems because you get, for example, you get shrink sleeves, you get problematic products that. So as Roger was going to allude to, we're going to tell you about a flotation tank. So what happens in a flotation tank is your polyolefins float and your PET sinks because of the specific gravity. But interestingly, PVC also sinks. So if we are getting PET bottles coming in and the shrink sleeve is PVC or PET, it'll contaminate our waste stream. So a lot of the time I'll get my LinkedIn profile is I get hounded by people wanting to know about all sorts of other biodegradable resins and PLAs and all that kind of stuff, which actually goes against the recycling stream. When your recycling stream is set up for PET, you want PET incoming feedstock. A lot of you is what your specification is. So standard specification in the industry all over the world actually is a 0.82 IV with an AA level of below 1 ppm. So the AA levels are quite important. AA levels are important because it manifests itself in terms of a fruity taste. So the last thing you want to do is spend millions on the taste of your water or your carbonated soft drink, and the packaging has an impact on the taste. So AA levels are below 1, that's something that we can control. IV of 0.82. This machine, it's residence time, as Roger was going to tell you. Residence time controls the IV, so we can make IVs up to 88, 90. And then the only other thing that's important is the color. So you want an L-star value of around 68, so that gives it a decent amount of clarity, because the last thing again you want to do is to put high levels of rPET in a bottle, and then the colors aren't manageable. So IVs are important, color values are important, and AA levels are important. Bottle sorting, bottle cleaning. After that, bottles chopped up into flakes, flake sorting, and flakes cleaning. Both automatic and manual. So remember all the steps that we come from, and this is to get us here. Now what happens here is you're feeding in flakes. So there's different kinds of flakes. You get different kinds of qualities. So the first step in a flake is called a cold wash. So a cold wash flake is a rudimentary flake that's not ready to become a food grade yet, it's just step 1. We ultimately end up three steps later with what is called a super wash flake. So the super wash flake has been processed and cleaned for enough time so that we can prepare it to go into the SSP, which SSP is then a chamber-based decontamination material and we get it ready to become a food grade packet. Answer any questions? It takes away the yellowness index and the color equation. So you can have various levels of green. An international standard, if you're out in the market buying the spec would be around 10% white food. That's the feedstock. That's the feedstock. Yes. So we control white food by around 10%. Prepare the flakes correctly. Yeah? Are fed through those two machines and then here, and goes into the extruder at 255 degrees. So the flakes that you saw have gone through the extruder, and they've now become an amorphous chip. So not yet. How many of these are on these bags? Over 1 billion. And if an amorphous chip is converted into rPET pellets, that rPET pellet is made to a certain specification, a 0.82 IV intrinsic viscosity of an L-star value of 68 and of a AA level of less than 1 ppm. So that's the global specification that we make a food grade rPET to, and that rPET is then sold both locally and internationally.